So flow duration curve, let's study on something about it. It won't take more than 3-4 slides. 3-4 slides and we are done then. There are two diagrams depicted on your slide. One here and second here. Both diagrams represents what? Daily discharge in a stream, daily discharge in a stream versus not time. And if you write here time, then it is hydrograph. But here it is percentage the probability of accidents. This is 10% of probability of accident, 10, 20%, 30%, until 100%. And discharge here is cubic, or you could write in millimeter or meter per day. Millimeter is not a good unit for the depth. So it's a millimeter per day, depth of flow. And we can take here like this. This could be meter in even for some rivers. So cubic is fine with us that we measure the flow in cubics. So that you look at 0 to 350. Now cubic means what? 350 cubic is amount, something you will find in small tributaries. In bigger canals like Narmada Canal, it is 5,000, 6,000, and in upper reaches it is 10,000 cubic meter per second. Sabarmati River, if you go upstream somewhere near Himatnagar, and if it is flowing during the rainy season, then the flow in that is around 5,000 cubics meter cube per second. It's a small river, it's not that big. So highest flow during the flood of 2006 was 14,000 cubic meter per second in the Sabarmati, and that too in Paladi area. So 14,000 cubics. So you could assume this 350 mark, that is a small flow, it's a small creek. It's a small creek meeting a major river. So now understand the kind of flow duration curve. So flow duration curve is about that discharge versus its percentage probability of getting equaled or exceeded by that amount. Like this river, this first solid river is having flow of 400 cubic, the probability is 0. Say in no time of the year, this particular river will have a flow of 400 cubics. Are you getting this? But if I say 100 cubics, then you draw a straight horizontal line here and some intersecting somewhere here, and if you bring it down, then 50%. So 50% times or more, it means 50 times 50% of the टाइम, मतलब एक साल में 360 दिन गिन रहे हो तो 180 दिन या उससे ज्यादा इसका फ्लो है वो 100 क्यूमेक से ज्यादा होगा. इसका मतलब ये हुआ being equaled or exceeded by that amount. So flow duration curve give us probability of flow in a particular river being equaled or exceeded by that much time period or by that much value. So this is 50% probability. 50% of time. This gives probability. It's not exact amount. This is something which is based on previous data, like 20 years, 30 years of data. Somebody has done the calculation and he has drawn this curve, that this is a particular curve for Sabarmati and it represents. Now, one thing. Second thing, first is a solid line and it doesn't have zero values anywhere. Even at 100% surety, you could say it will have 50 cubics. Are you with me? All of you? This, if you look at my cursor, then at 100% probability, means all the time throughout the year, this particular river will have at least 50 cubic of water. Means it's perennial river. Some flow is always there. But if I talk about the second river, then this river here, this river doesn't have any flow for 100% probability. Even 90% no, 80% no, 70% no, only 65% probability of something like tending to zero. Even for 50, it is 30% probability. 50 cusack is a 50% cusack, it's having 30% probability. So this kind of river which doesn't have 100% probability of the flow, then those kind of rivers are perennial, and those lesser than this are intermittent or ephemeral rivers. And similarly, here in the left chart, you could find that perennial river is this. This is very horizontal, probability is very high, 100% and good flow. Here, look at this, very good flow here with the almost stable flow throughout the year. So this is a perennial stream with low variability. This is also perennial 100% here, but high variability, and this is a intermittent or ephemeral stream. The third one. So FDC, इसको क्या कहते हैं? दूसरा discharge frequency curve. Flow means discharge, duration means frequency, and curve is curve. So flow duration curve, and second name for the same curve is discharge frequency curves. Now look at this. If you construct a dam, if you construct a dam somewhere on the stream, though earlier it was solid, this was solid, and with 100% probability of the flow, there was hardly 10 Q max. Look at this, 100% probability that throughout the year 10 cubic at least will be there in the river. But with construction of reservoir, this flow with regulation means you have constructed either weir or a dam. So when you constructed here some weir, then this dotted line is generated, and now you could say that this river will have throughout some flow. How much flow? 25 Q max of flow throughout the year. So this is the effect which you are creating. Being civil engineer, you are creating structures, and those structures are causing perennial flows in the river. Like in the Sabarmati, we have Vasana barrage, and we have certain kind of flow always flowing because of some escape other structures also into the Sabarmati while it is passing through the Ahmedabad city. So this is these structures are called regulation structures. This is example from the Subramanya book. Similar example, discharge is on this axis. This is log graph. You could either draw a simple graph where if there are so many observations, so many data sets are available, then you have to go for a logarithmic graph like this, and discharge is here, and onto the x-axis is the PP, that is percentage probability of getting equaled or exceeded. This is how it is written here. So generally what is done, that the stormwater system which we design, they are designed based on this, that exceedance value of a PP value of 95% or 98%. But 2% chances are there would be flooding in your area, or 5% chances are there that your area would get flooded, even if you have designed properly your network system, drainage system, stormwater or sewerage system. So engineers should not be blamed. We are designing to economize. We are designing to optimize the project cost. If we do not optimize, then we can't really go for so many projects at a time. So that optimization is required. Basically, this is the way we reduce the cost of the projects, that we are considering some factor in which the things we let that happen, let the flooding happen, let the drought take place. We cannot assure 100% water supply all the time. So that is beyond the possibility of human efforts, I would say. So this is graph of the real data. Real data is given here, that daily flows are given to you, and you are supposed to calculate where the 50% dependable flow and 75% dependable flow. Now word dependable is used here. 70%, then how much is the Qmax at 75 probability, and at 50% what is the QMAC at that. So at 50% level, you are assuring that that much flow would be available at least for 50% of the time or 75% of the time. So that is what is the dependable flows. This is simple way of construction of this, that given data, discharge data in river is arranged in descending order. Like this graph you see, that we have to arrange the given data in descending order, and we use this simple equation that this is the number of observations plus 1. M represents the value at which you are working into 100. This is the percentage value of PP to calculate. So this is only the number of observations. This indicates at which you are working. This is the total number plus 1 into 100. That gives the percentage probability which we have drawn on x-axis. On y-axis is what the discharge value. So this FDC we are getting, flow duration curve, like this. Now daily mean discharge values are given in, this is given in range, number of days flow taking place here. So total column of 2, 3, 4, 6, 19, then value of flow is between this 19, 14, number of days 62, 100 and 94, 230, 172. इतने दिन इतना पानी बह रहा है, इतने दिन इतना पानी, इतना दिन इतना पानी. तो आपको जो इतना पानी है वो 194 डेज पे मिल ही रहा है. 235 मैक्सिमम है, मतलब 365 दिन तो पानी मिल ही नहीं रहा है. नदी में पानी है ही नहीं 365 दिन. तो ये जो पानी की कम से कम वैल्यूज हैं, कहाँ पे है? डेली मीन डिस्चार्ज to 5 days. ओके, सॉरी. अभी हम इसको जो क्यूमुलेटिव टोटल निकाल रहे हैं वो इसका क्यूमुलेटिव है 6 + 19 ये आ गया. फिर पीपी निकाल रहे हैं mn+1. this 6, n is this 1096 और ये n is 1096 here total. number of column this +1 into 100. ये वैल्यूज आई है यहाँ पे. ये वैल्यूज को हम यहाँ पे ड्रॉ कर रहे हैं, तो ये ग्राफ मिल रहा है. तो ये FDC है. ये क्वेश्चन जो लास्ट दिया हुआ है आपका, जो ट्यूटोरियल 6 में, ट्यूटोरियल 6 का जो लास्ट न्यूमेरिकल है वो यही है. आपको FDC मार्क करना है, आपको अरेंज करना है उसको ऑर्डर में, डिसेंडिंग ऑर्डर में काम करके m की वैल्यूज फाइंड करनी है, और m की फाइंड करने के बाद PP की वैल्यू फाइंड करनी है. फिर आपको ड्रॉ करना है, और फिर 50 पे और 75 में इस क्वेश्चन में था, हमें मार्क करनी है. तो हमें जो फ्लो है 75 और 50 का मिल रहा है. तो दीज आर दी FDC वैल्यूज.